All right, let's take a look at some triangles. I know it's been a while for some of you guys, going way back to junior or sophomore or freshman year geometry, but some key features you need to know. You need to remember that triangles add up to 180 degrees. You need to know about vertical angles. Similar triangles, the sides are in proportion, so you can set up proportion where you can cross multiply. And then there's going to be a little bit of trig in this one, so I'll kind of hit all of these as we go through it. So number one, they do this a lot in the geometry. It says figure not drawn to scale. They also, a lot of these are going to be in the no calculator section, or they're going to be in the free response. So most of these aren't multiple choice. So in the triangle above, A equals 34. So I can go ahead and I can just draw 34 degrees in there. What is the value of B plus C? So I don't know what B and C are separately, but since the whole thing has to add up to 180 degrees, I can just take away 34 from that, and I get a grand total of 146. All right, looking over here at number 3, lines RS and T intersect below. And what is the value of X? So X represents this angle outside here. So we're trying to find that outside angle. So I'm going to use some features here to kind of jump in. Let me kind of zoom in on this a little bit too. So first thing is, straight lines form 180 degrees. So if this is 106, this other piece right here, if I subtract that from 180, it's going to be 74, because that straight line has that up to 180. Well, now I have a triangle right here that I can solve for. So 74 plus 23 is going to be 97. And to get this missing angle, I need to subtract from 180. And that's going to give me 83, which goes here. And then to find out what X is, I need to kind of jump out of the triangle, and I need to make those two add up to 180. So I'm going to do 180, take away the 83, and actually I get back to having an answer of 97 degrees. There's also a theorem, so I'm going to go back and kind of erase some of this stuff in here. There's also a theorem called the exterior angle theorem that says for any triangle, so like let's say you have some sort of triangle, this outside angle here, we'll call it X, it's always going to equal these two remote or far away angles added together. So X is always going to equal A plus B. So the second that I found out that this was 74, I could have figured out what X was by just adding those two together, and I could have saved a little bit of time. All right, shrink her back down. Next one, number 2. This one's a little bit tougher. You have two triangles kind of nose to nose facing each other. They try to trick you on this problem. So remember that when two lines cross, these angles inside here, for instance, this angle and this angle, they're equal to each other. They're called vertical angles. But they kind of trick you up top because this line isn't a true line. It actually kind of comes up and then it just bends all of a sudden. So you can't apply that property here. So we're going to have to use something a little bit different. So let's see what kind of clues we got. We have two isosceles triangles. So remember, isosceles triangles have two equal sides, and they also have two equal angles. So for instance, since these two sides are equal, I know that those two angles have to be equal. And same thing over here on the other side. If these two are equal, then these angles have to be equal. All right, so if 180 take away z equals 2y, and y equals 75. All right, so I have my first clue. Y is 75 degrees. So let's plug that into this equation. 180 take away z equals 2 times 75, which is 150. So I can solve that. 180 take away 30 is 150. So I know that z equals 30, but that's not what they wanted. They want me to find the value of x. So let's plug z in. We have z is 30. Well, since this triangle adds up to 180, I'm going to do 180, take away 30, and that leaves 150. But then I'm going to split these two up evenly. All right, so I got to divide that by 2, which tells me that each angle by itself is 75. And then finally, we need to jump out of this triangle and find that x on the outside. So 180, take away the 75, is 105 degrees. So final answer here is 105. You also could have used that exterior angle theorem that we talked about in the last problem. Those two far away angles have to add up to that outside angle there. All right, number 4. Let's kind of get this stuff out of here. See what we got going over here. In ABC above, what is the length of AD? So AD is this piece right here. That's what we're trying to find. Well, one thing I kind of see is that if this angle over here is 60 and this is 90, that means he's got to be 30, which those two added together means we have another 60 up top, which means we have a 60 over here, and it looks like we have an equilateral triangle that's 60, 60, 60, which means that if this whole side over here is 12, that means this side is 12, so half of that is going to be a grand total of 6. So the correct answer here is B. All right, looking at number 5, MQ and NR intersect at P, and then we have a congruence. Here we have NP equals QP. So NP equals QP. And M to P, that's how it's written. There's no symbol there. It means the distance from M to P is equal to P to R. So that tells me that I have an equilateral triangle down here on the bottom. So I know that this angle is actually going to be equal to that angle. So what is the measure in degrees of QMR? So first of all, where the heck is angle QMR? The most important letter is that middle letter, because that's the vertex. So QMR means we're trying to find this angle right here. That's going to be the answer to the problem. All right, well, let's see what we got, and let's kind of use it. So it looks like I have a 60 and a 70. That adds up to 130 degrees. So subtracting from 180 leaves me with 50. Don't know if I need that, but that's 50 degrees. I don't think I'm going to need it. I'm going to use that 60 and use the straight line to get those two. So 180 minus 60 is 120. So that way I have this straight line being formed here. And now on the bottom triangle, it's supposed to be 180 degrees. I've just used 120. So that means I have 60 degrees left for both of these two angles. But since they're equal, I need to divide that by 2. And that will give me my final answer of 30 degrees for both of those bottom angles. All right, number 7 over here. So number 7 says in the figure above, lines L and M are parallel. So parallel lines, remember I can put a little arrow on them to show that they're parallel. The key thing you need to know about parallel lines is if you have two lines that are parallel and you have a transversal cutting down, it creates 8 angles where 4 are equal to the other 4. So for instance, this angle and this angle form they're vertical angles. But when you slide down to the next intersection, those are also going to be equal. They're all corresponding to each other. And then I'd have these other angles here. This big obtuse angle and this big angle is going to equal that one and that one. And that pattern kind of always plays out. So I'm going to use that fact in the question up above. So it says y equals 20. So if y equals 20, sliding up this line right here, it looks like this is also going to have to be 20 because those lines are parallel. Z is 60. So Z's got to be 60. And so this one's not too bad to find out what X is. So far I have 20 plus 60. I have 80. So to get 180, it looks like X has to be 100. So the correct answer here is B. Number 6. Got a lot of stuff going on here. Triangles crisscrossing. Let's see what we got going. So RT equals TU. So I'm going to just color these. So RT, that blue line, is going to equal TU, that blue line. So right away, I know if I have an isosceles triangle that these two angles should be equal. And they give me the vertex angle. They told me this top angle here is 114. So let's go ahead and let's subtract from 180. So 180, take away 114, leaves me with 66. And got to divide that up by 2. So that tells me that this is 33. And it tells me that this is 33. So next, let's see. I'm going to kind of focus on this triangle right here. Focus on that big triangle. And if I look at that big triangle, I have 33 degrees on this corner. I have 31 on that corner. So that right there is 64. And if I subtract from 180, that leaves 116 degrees. Whoa. That leaves 116 degrees right here for this corner. And then I can use my little straight line rule. If I kind of blow this up, if I kind of blow up what's happening right here, I have 116. So to figure out what x is, I just have to subtract from 180, which I've already kind of done that. Correct answer is going to be 64. So C is going to be the correct answer here. All right, number 8. See what we got going on. In the figure above, ADE intersects BE. Intersect doesn't mean anything. It just means it crosses. If x is 100, so x is 100, what is y? All right, so we're trying to figure out what y is over here. Well, I'm going to work on the triangle on the left. I have 100 plus 20 is 120. So to get to 180, that means I'm missing 60 degrees. And these two lines here do cross and form a nice X. So that means that vertical angles, this is 60. So now I can jump over here in the triangle on the right. 60 and 40 is 100, which means y has to be 80 degrees. So the correct answer for number 8, C. All right, now we're getting into some similar triangle stuff here. So let's kind of see what's going on with this one. A summer camp counselor wants to find a length x in feet. So x is the length of this side of the triangle right here. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be, and then they give me the 4 numbers, and then they use the word respectively. All right, so whenever you see that word respectively, that means it goes in order. So we have AB was the first one, so that's 1800. And then EB came next, so that's the 1400. And then BD came, so that's the 700. And then CD was 800. So those are the 4 numbers that they gave me. Angle AEB and CDB have the same measure. So it looks like that this angle is congruent to that angle, which is really helpful because since I have vertical angles in here in the center, since those two match up, that means that this third angle has to be the same. So we basically have 2 triangles. We have a big and a little triangle. Now the tricky part is to find out what side corresponds with the other side. And here's where it's important to look at the marks of the angles. So I can see right now that this 1400, that 1400 is between the 1 and the 2 arc. So that goes with this 700. And right there I see a relationship. The relationship between 700 to 1400 means this big triangle over here is twice as big. It's 2x as big. So every side is going to be double. So if we're trying to find the length of AE, that's between the 1 and the 3 arc. That should match up with this side. So it should be double 800. So the correct answer here is going to be 1600. All right, right next to number 9, we'll look at number 11. Same type of idea, I believe, on this one. We have parallel lines. So if these two lines here are parallel, that means that we also, another fact from parallel lines is you have alternate interior angles, meaning that this angle equals that angle, and this angle equals this angle. Then we have the vertical angles in the middle are going to be equal. So when you line up pieces, you have this 5 between the 2 and the 3 arc goes with the 10. So again, we have a 2-to-1 relationship. So it will help me, because if this side right here is 8, this short side over here is 4. Final answer is, what is the length of CE? Well, CE is this whole thing. So I need to add the 8 plus 4 to get a final answer of 12. All right. Number 10, triangle above, ABC is similar to DEF. What is the value of the cosine of E? All right, so quick trig refresher. Cosine is the adjacent leg over the hypotenuse. So I'm looking for the cosine of angle E. So that means if I put my guy up here, or if my reference angle is E, the cosine for E would be, well, the adjacent leg is the one right next to me, which is ED, and the hypotenuse is EF. All right. And if these two triangles are similar, they should have the same exact relationship. So that means it's the same thing as if I stand on B, the cosine is going to be 12 over 13. So the correct answer here would be B. All right, looking at number 12, it says triangle ABC, the measure of B is 90 degrees. BC is 16. All right, so let me just start drawing this thing out. Angle B is 90. So I have a triangle where angle B is 90. Just going to put A up here and C over here. BC is 16. AC is 20. Then it says triangle DEF. So DEF is similar, so same shape, but each side of DEF is 1/3 the length of the other side. So DEF is much smaller. So DEF. And it said that they corresponded, so D corresponded with A, E went with B, so that's kind of how I knew that went. But it says it's 1/3 the length. So I could start writing down 1/3 of each side, but let's keep going. It says, what is the value of the sine of F? Well, the sine of F, so let's talk about that real quick. The sine of F should be opposite. So if I'm standing here, it should be opposite over hypotenuse. So it should be DE over DF. Now, since these two triangles are similar, sine of F is also going to be the same thing as the sine of C, which is going to be opposite over hypotenuse. Now, I don't really know what the opposite is. I could do the Pythagorean theorem, so I could call this x and say, all right, what's x squared plus 16 squared equals 20 squared? And I could go ahead and I could solve that. But I'm actually going to use another trick. I know that a lot of times right triangles, especially on tests, they follow the format of 3, 4, 5. All right, that's a Pythagorean triple. And I notice that these two numbers are exactly 4 times bigger. If I times that by 4, I get 20. If I times this by 4, I get 16. So I think if I times this by 4, I'm going to get 12. So the sine of C is 12 over 20, also known as 6 over 10, also known as 3/5. So I think they would probably accept 3/5 or they would accept 0.6. Either one should work out. All right, number 13, triangular shelf system. Total height of the system is 18 inches. What is the maximum height? A shampoo bottle. So we're trying to figure out what is going to be this maximum height right there. And we know that the total is 18. Well, if you have parallel lines, so this word parallel here was pretty important. If you have parallel lines here and here, all right, those lines get broken up proportionally. So on the side, I see that I have x, I have 3 times x, and I have 2 times x. And it also is true that this line and the red line and then this black line down here at the bottom, they're all going to have to be proportional the same way that that side line is. All right? Meaning that the red line is 3 times bigger than the black line. The green one's 2 times bigger than the black line. So the way I'm going to solve this is, since we have pieces, we have 2x, 3x, and 1x. We have this broken up into 6x. So if I work that out and say, well, let's let x equal 3, that means that I'm going to have 3 here, and I'm going to have 3 of those, so that would be 9. And then I'm going to have 2 of those 3s, that would be 6. So now, as you can see, I have the height, I have the 18 broken up into the correct ratio, where you have 1 to 2 to 3. So the shampoo bottle is going to be 9. All right, number 15 over here. Triangles ABC are shown above. Which of the following is equal to the ratio? We want BC over AB. BC over AB. Well, looking at these two triangles, it looks like they're going to be similar. You know, if this is 90, and I do, the other two have to add up to 90. So if I do 90 minus 32, I'm going to get 58. Well, if I look at this other triangle, I have a 90 and a 58, so that means that this has to be 32. So that means that I have some sides that correspond with each other. BC should go with DF. So BC should correspond to DF. And AB, I'll make him in green, AB is across from the 90, DE is across from the 90. So I think BC and AB are equal to DF over DE. So that would be a correct answer of B. Number 14. BD is parallel to AE. What is the length of CE? So ultimate goal here is how long is this side? Well, a couple things that I know to be true, and this might be easier if I kind of break them up. Let's focus on this little blue triangle. All right, it's 6 and it's 8. And it kind of looks like my good friend, that Pythagorean triple, that's 3, 4, 5. That's the 3 doubled, that's the 4 doubled. So this is going to be 10. So that kind of gives me a nice little clue right there. CD is 10. But that little blue triangle is going to be proportional to the whole thing. This big triangle. And they do give me one side of that big triangle. They tell me this side's 18. Now, since these two are similar, I can see the scale factor. 6 times 3 will get me to 18. So every side is 3 times larger, which means the bottom is going to be 8 times 3. The top is going to be 10 times 3 for 30. And that's exactly what I needed. I needed this entire top. So the entire top there is going to be 30. Number 16, similar type of triangle. Busting out trig again, it looks like. So let's see what we got. In the figure above, the tangent, the ratio from angle B, so if I put a little guy up here on B, the ratio of tangent is opposite. So remember, let me just write this down. Tan is opposite over adjacent. All right. So this would be the opposite, and this would be the adjacent. Or if I'm looking at the big triangle, this would be the opposite, and this would be the adjacent. Okay, it depends on if you're just focusing on the little one or the big one. All right. So let's kind of go in here and let's put some work in, see what's going on. So it's 3 to 4. We have BC is 15. So that means this entire side over here is 15. And DA, that little piece right there, is 4. What is the length of DE? All right. Well, let's kind of see what we can do here. So I'm going to start off with the clue about the tangent of B being 3 to 4. So we have a ratio of 3 to 4. You know, and if I'm going to focus on the bigger triangle, because the only value they really give me that was helpful was they did tell me that this side over here was 15. So if I have a 3 to 4 ratio, well, again, there's my triangle. There's my 3, 4, 5. But they told me that BC was 15. So it looks like it's scaled up by a factor of 3. So this bottom, even though it's in a ratio of 3 to 4, it's really, the true length is going to be 9, and it's going to be 12. Because 9 over 12 is still 3 to 4. So that kind of helped me out. So now I have the long sides. All right. I have 15, I have 9, and I have 12. And if DA is 4, so DA is 4, well, subtracting from the 12, that means this piece up here is 8. And if the ratio is 3 to 4, 3 to 4 would be 6 to 8. You know, 3 to 4 is the same ratio as 6 to 8. So I think I just found DE. Correct answer is 6. That one was pretty tough. And I believe that's it for us. So that one started off pretty easy. You know, 1 through 8, 9, 10. And then it started getting tougher. And then we got into trig. It actually started getting really tough there towards the end. We're going to spend a whole unit, though, just on trig to kind of refresh ourselves.